example from chapter 13.7. Again, we want to calculate a flux through a closed surface S, where your S is the surface of this unit sphere with this vector field F. Now, so let's draw a picture. So we have this sphere. This is a unit sphere with the equation x squared plus y squared plus c squared equals to 1. And the boundary of this sphere is your S, and inside domain is your E. Okay. So now we know that divergence theorem says that the flux through a closed surface S equals to the volume integral of the divergence of F over the domain E. Now, so first thing we should do is to calculate the divergence of F. Volume V. Now our vector field F is x cubed comma y cubed comma c cubed. So this should be x cubed x cubed plus partial over partial y of y cubed plus partial over partial c of c cubed. Now, if you evaluate these three partial derivatives, you will get 3x squared plus 3y squared plus 3c squared dv over the solid domain E. Now, since your domain is a sphere, and here we have a term with 3x squared plus 3y squared plus 3c squared, obvious choice to use the spherical coordinate system. So the obvious choice is to use the spherical coordinate system. So let's do that. Now in spherical coordinate system, x squared plus y squared plus c squared is rho squared. So this integrand becomes 3 rho squared. Now this volume element dv equals to rho squared sine phi d rho d theta d phi. Rho is the radial distance, theta is the polar angle, and the angle phi is measured from the positive c axis. Now rho goes from 0 to 1 because we have a unit sphere. Theta goes from 0 to 2 pi. That's the angle on the xy plane. X, Y, and Z. That's your theta. This is your angle. Let's say this is your distance rho, and this angle is phi. And finally, angle phi goes from 0 to pi. Let's simplify the integrand. We have 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, d theta, d phi. 3 rho to the power 4 sine phi, d rho, first variable of integration is rho, therefore we can treat 3 sine phi term as a constant, and so we have 3 sine phi. If we integrate rho to the power 4, you should get rho to the power 5 over 5. Lower limit of rho is 0, and the upper limit is 1. Okay, and so simply this equals to 3 sine phi times 1/5, because the lower limit will give you 0, d theta d phi now the pi. The next integral is with respect to the theta variable, so this entire integrand can be treated as if it is a constant. So we have 3 sine phi over 5, and integral of 1 with respect to the theta variable is theta. Phi. And if you apply the upper limit, you will get 2 pi. So you have 3 sine phi over 5 times 2 pi minus the lower limit will give you 0. So let's factor out the constant terms. We have 3 and 2 pi, which is 6 pi, and in the denominator we have 5. So the constant term should be 6 pi over, this should be pi, 6 pi over 5 times integral of sine phi d phi. Integral of sine phi is minus cosine phi. And now we are ready to apply the limits. So we have 6 pi over 5 times minus cosine pi minus, then you have minus cosine 0. Okay. Cosine pi is -1. Cosine pi is -1. So -1 times this negative becomes +1. So you have 1. Minus times minus is plus, and cosine 0 is 1, equals to 6 pi over times 6 pi over 5, and this is nothing but 12 pi over